Welcome back, everybody, for another deep dive. This time, we're going under the hood, so to speak, to explore the world of aluminum in cars.
Aluminum! Really?
Oh, yeah. It's more fascinating than you might think.
Okay, I'll bite. I mean, I know cars use aluminum, but...
It's everywhere.
Okay.
We've got this technical deep dive on aluminum die casting. And
die casting sounds heavy.
it is, in a way. But the results are lightweight. Get it?
Okay, I see what you did there. But seriously, why should we care about aluminum in cars?
Well, first off, it's tied to some major trends in the auto industry. Think lightweighting for fuel efficiency and the move to EVs.
Right, lighter cars need less energy.
Exactly. But aluminum's properties also make it perfect for all sorts of car parts, not just body panels.
Like what?
Let's start with the engine. The heart of a traditional car.
Yeah.
Why is aluminum so popular for engine blocks and other components?
Well, for starters, it's incredibly lightweight compared to steel. That's a huge plus when it comes to fuel efficiency.
So it's all about being light.
Not just light, it's also surprisingly strong and can handle the high temperatures and pressures found inside an engine.
So it's got brawn, Andy brains. It's light, but can take the heat.
Precisely. And there's a specific type of aluminum often used for these parts, called alloy 380.0 ADC12.
Alloy. So it's not pure aluminum.
Right. An alloy is a mixture of metals. In this case, you've got aluminum with silicon and copper.
Ah, so it's like a supergroup of metals, each bringing their own strengths to the party.
I like that analogy.
But why this particular blend for engines?
Well, it has excellent fluidity when molten, which means it can flow easily into complex shapes when being cast.
I'm picturing those intricate engine blocks with all the nooks and crannies.
That's exactly what I'm talking about.
Hey.
But it's not just about filling the mold. It's got to be tough. Alloy 380.0 ADC12 has good mechanical properties.
Meaning?
It's strong and durable enough to handle the wear and tear of an engine, plus it's relatively cost-effective.
So it's like the Goldilocks of engine materials. Strong, lightweight, and affordable.
You could say that. It's no wonder Alloy 380.0 ADC12 has been so popular in the auto industry.
Okay, so aluminum is great for engines, but what about the rest of the car?
Well, think about what's connected to the engine.
The transmission.
Yeah, you'll find aluminum in transmission cases, valve bodies, even parts of the clutch and differential.
Same reasons. Lightweight, strong, good at handling heat.
Exactly. But its use goes even further. It's used for structural parts of the car, too, like parts of the chassis and even the body itself.
Wait, structural. I thought of aluminum as being, well, flimsy, like a soda can.
You'd be surprised. We're talking about using aluminum for major structural components, and this is where it gets really cool.
I'm intrigued.
There's this growing trend toward mega castings.
Mega castings sounds intense.
It is. These are huge, single-piece aluminum components that can form a big chunk of the vehicle structure.
Like, what parts are we talking about?
Think of the entire floor pan of a car or the rear underbody structure. Instead of welding together tons of smaller parts, they cast these large sections as single pieces of aluminum.
So it's like they're making a giant aluminum Lego block for the car.
In a way, yeah. And it's not just about simplifying the assembly process.
I was going to say, fewer parts, fewer welds. That has to streamline things.
Absolutely. But it also contributes to a stronger and more rigid vehicle structure.
Interesting. So one big piece can actually be stronger than lots of little ones joined together.
Exactly. And a stiffer structure leads to better handling, a smoother ride, and even better safety in a crash.
Okay, so from engine blocks to transmission cases to these mega castings, it's clear that aluminum's impact on cars is huge. But what about the future of cars? Electric vehicles. Does aluminum have a role to play there?
Big time. In fact, you could say that aluminum is even more crucial for EVs. But that's a story for after the break. We were talking about aluminum being even more important for electric vehicles.
Right, and I can see why. Lighter materials mean better range, right? Less weight to lug around.
Absolutely. But it goes way beyond that. Aluminum plays a crucial role in EV battery systems, too.
Now, that's interesting. How so? I wouldn't have thought of that.
Well, think about the challenges with EV batteries. They generate a lot of heat.
Right.
And they need protection from damage and electromagnetic interference.
Makes sense. They're like the heart of an EV. Got to keep them safe.
Exactly. And guess what? Aluminum helps with all of that.
Okay. You've got to explain that one.
No problem. First off, aluminum's an excellent conductor of heat.
Is that a bad thing?
Not in this case. It means aluminum components can dissipate heat away from the battery pack, keeping it at the right temperature.
So it's like a built-in cooling system for the battery.
Pretty much. Then there's the protection aspect.
Right. Got to keep those batteries safe from bumps and stuff.
Aluminum's strong and durable, so it's used to create protective housings and structures around the battery pack.
Ah, so it's like a shield.
And then there's the electromagnetic interference.
You mentioned that earlier. I don't really get what that means.
Basically, electric vehicle batteries and motors can generate electromagnetic fields that could mess with other electronics in the car.
Oh, I see. Like interference with the radio or something?
More serious than that, it could interfere with critical systems.
Wow, that's kind of scary.
But aluminum can help prevent that. It acts as a shield against electromagnetic interference.
So it's like a bodyguard for the battery, keeping it cool, protected, and making sure it plays well with others.
That's one way to put it.
Okay, but what about the actual parts that make an EV move?
Yeah.
The electric drive unit, right?
We got it. The motor, inverter, gearbox.
It's got stuff.
Yeah. And guess what? You'll find aluminum there, too. Motor housings, inverter cases, even gearbox components.
So it's really everywhere in an EV, huh? Not just the body and battery.
Yep. Lightweight, strong, handles heat well. Same reasons it's good for combustion engines.
It's like the multi-tool of the car world.
Huh. That's a good one.
But I gotta ask, how do they make these aluminum parts in the first place? It's not like you just pour molten metal into any old mold, right?
You're right. It's a bit more sophisticated than that. The process is called die casting.
Die casting. Sounds kind of ominous.
It's actually pretty fascinating. They inject molten aluminum under high pressure into a super precise mold.
So they take this liquid metal, crank up the pressure, and bam, out pops an engine block.
Not quite bam, but you get the idea.
So it's like a high-tech metal injection molding.
Yeah, you could think of it that way. The molten aluminum fills every nook and cranny of the mold, creating incredibly complex parts.
I'm picturing those molds being incredibly detailed.
They are. And the temperatures involved are intense, well over 1,000 degrees Fahrenheit.
Wow, that's hot. Melts more than just aluminum, I bet.
No kidding. And the whole process happens super fast, often in just seconds.
From molten metal to finished part in seconds. That's impressive.
It is. But it's not over yet. The part then goes through finishing steps to make sure it meets the exact specs.
Makes sense. These are important parts. You don't want any defects.
Exactly. Quality control is paramount in die casting. They use X-rays and other methods to check for flaws.
So they can see right through the metal.
This is essential. These parts have to withstand a lot of stress and be super reliable.
Like you don't want your engine block cracking while you're driving down the highway?
Definitely not.
Okay, so die casting is how we get these aluminum parts. And we've talked about how aluminum is great for engines, transmissions, even structural components. Plus, it's perfect for EVs. But what about the environmental impact? Isn't aluminum production pretty energy intensive?
That's a good point, and it's something the industry is working hard to address. Aluminum production does require a lot of energy, traditionally from fossil fuels.
So there's a carbon footprint to consider.
Right, but the good news is that the industry is shifting toward renewable energy sources.
Like solar and wind power.
Exactly. They're also making aluminum production itself more efficient, and of course there's recycling.
Ah, yes, aluminum is super recyclable, right?
One of the most recyclable materials out there. It can be recycled over and over again without losing its properties.
So the aluminum in my car could end up in another car someday.
Absolutely. Or in an airplane, a building, you name it. The possibilities are pretty amazing.
That's really cool. So even though it takes energy to make aluminum, we can make that process cleaner and then recycle it to reduce the overall impact.
That's the idea. It's a big focus for the industry, and it's something consumers are demanding too.
Makes sense. People want to know that what they buy, especially something as big as a car, is made responsibly.
Absolutely. Sustainability is a key factor in the future of the auto industry, and aluminum is playing a huge role in that.
This has been really eye-opening. I never thought I'd be so fascinated by aluminum.
There's a lot more to it than meets the eye.
That's for sure. But I think we've covered a lot of ground here.
We have, from the basics of what aluminum is to how it's made, how it's used in cars, and what the future holds.
And we've touched on the environmental side of things too, which is super important.
It all connects. Materials, manufacturing, sustainability.
Well, folks, I hope you've learned something new today.
I know I have.
Aluminum is clearly more than just a lightweight metal.
It's shaping the cars we drive and helping to build a more sustainable future.
Thanks for joining us on this deep dive into the world of aluminum in cars. Until next time.
We've covered a lot of ground in this deep dive into aluminum in cars.
It's amazing to think about how much goes into something as seemingly simple as a car part.
It really is, from the material science to the manufacturing processes to the sustainability aspects.
And you mentioned before that there's even more to explore.
Absolutely. We've only just scratched the surface.
Well, let's dig a little deeper then. What other exciting developments are on the horizon for aluminum in cars?
One area that's particularly exciting is the development of new aluminum alloys specifically for automotive applications.
We talked about alloys earlier.
Right, but these new alloys are even more advanced.
Like, what kind of advancements are we talking about?
They're pushing the boundaries of performance. We're talking enhanced strength, better formability, even greater corrosion resistance.
So it's not just about making aluminum lighter, it's about making it even better at what it does.
Exactly, and this opens up a whole new world of possibilities for car design and manufacturing.
Give me an example.
Well, with stronger aluminum alloys, engineers can create thinner and lighter components without sacrificing strength.
So even lighter cars, which means better fuel efficiency.
Exactly. And longer range for EVs, too.
It's a win-win all around.
And there's another exciting area where aluminum is making a big impact.
Okay, I'm intrigued. Tell me more.
Additive manufacturing.
Additive manufacturing, you mean like 3D printing?
Exactly. 3D printing with metal is becoming increasingly common in the auto industry.
Wow, I never thought about 3D printed car parts.
It's happening. It allows engineers to create incredibly complex and intricate designs that would be impossible with traditional manufacturing.
So they could basically print an engine block or a suspension component.
Pretty much. It opens up a whole new world of design freedom and optimization.
So not only is it lighter, but they can make it into any shape they can imagine.
You got it. And it's not just about design. Additive manufacturing can also reduce material waste and lead to more efficient production.
So it's a more sustainable approach as well.
Exactly. And this ties into the broader trend of sustainability in the aluminum industry.
Right. We talked about the shift toward renewable energy and better recycling technologies.
And there's more. One exciting concept is closed-loop recycling.
Closed-loop recycling. What's that?
It's about creating a truly circular system for aluminum.
I'm listening.
Instead of just generally recycling aluminum, closed-loop recycling focuses on recovering aluminum from specific products and using it to make the same products again.
So aluminum from a car gets recycled into new aluminum specifically for cars.
Exactly. It keeps the aluminum within a specific industry, reducing the need for virgin aluminum production.
That's pretty amazing. It seems like the aluminum industry is really taking sustainability to the next level.
They are. It's a combination of innovation, technological advancements, and a commitment to reducing environmental impact.
It's inspiring to see how this seemingly simple metal is playing such a big role in shaping a more sustainable future.
It really is. Aluminum is more than just a lightweight material. It's a key player in the evolution of the auto industry and the transition to a more sustainable world.
This deep dive has been incredible. I've learned so much about aluminum and its impact on our lives.
It's been a pleasure sharing this journey with you.
So the next time we see a car on the road, let's remember all the amazing science and engineering that went into making it.
And let's appreciate the role that aluminum is playing in making our cars lighter, more efficient, and more sustainable.
Thanks for joining us on this deep dive into the world of aluminum in cars. Until next time.